I'm going to look at how much energy is stored in a capacitor as we put more and more charge onto that capacitor. For a capacitor, the charge that it's raised to is going to be proportional to the voltage difference between the two conductors in the capacitor. For a parallel plate capacitor, we have a specific value for the capacitance C, but in general, for any two conductors that you give equal and opposite charges to, there'll be some potential difference in between them, and it's a linear relationship. So if I double the charge, I double the potential difference V. Now, imagine I have a capacitor and I'm just going to put some charge on it, and then I put some more charge on it, and then some more charge. It's always going to be following a linear relationship. It's going to go through the origin, and we can think then about how much energy is stored, because this voltage that you've raised the capacitor to, that is the energy per unit charge. So in this charge voltage plane, the area underneath this curve, which is a straight line, so that area is how much energy is stored. And the area of a triangle is a half base times the height, so the energy stored in the electric field of a capacitor is going to be a half Q times V. We have now two equations in the variables of Q, V, and C. So I can rewrite this energy stored in the capacitor if I want in terms of the pair of capacitance and voltage. So I replace Q with CV. I'll get a half CV squared. Or I could write it in terms of charge and capacitance. And I would do that by replacing the voltage with Q over C. So I could also write this energy stored in the electric field of a capacitor is Q squared over 2C.